we move to our next speaker, which is Beskin, and who will explain us how pulsar slow down. Hopefully.
I am alone from organizing committee who presents the talk, but my talk consists 6 steps. The first step concerns the vacuum magnetodipole radiation. It's well-known expressions for talk, but if we consider this talk in more detail, because the only reason of pulsar breaking in the ampere force, that is the currents, surface currents flowing in the magnetosphere. And if we expand this expression in the power of this small parameter, that we see that there are 2 terms. One term concerns the disturbance of the current, and another one is disturbance of normal component of magnetic field. And if we consider well-known Deutsch solution, when by construction disturbance of normal component is equal to 0, we found that all energy losses connects with the first term. But if we consider Landau-Lifshitz solution for point dipole, we found the situation is different. Only 2/3 of energy losses concerned with the first term, and 1/3 with another one, because the only difference in these 2 solutions is very, very small additional magnetic dipole, which certainly doesn't change the energy losses, but this additional term change drastically the current system, which result in the pulsar breaking. So, important conclusion that 2 terms can play a role in energy losses of rotating sphere, magnetizing sphere. The next step concerns the pulsar magnetosphere, which was started many, many years ago. Mestel formulated so-called Mestel equations. There was postulated the pulsar equation. There were a lot of solutions, even in 70s. And we obtained the solution for the case when there is no longitudinal currents flowing in the magnetosphere. Later, this result was confirmed by Mestel group. You see, is sorry. Okay. This part is approximately the same. And if we consider the orthogonal case in the equatorial plane, this is a picture from Mestel group, and I have drawn this structure with pencil. Very important conclusion that toroidal magnetic field on the light cylinder vanishes. This implies that no energy flux through the light cylinder. This implies that all energy losses are to be connected with the longitudinal current flowing in the magnetosphere. That is important conclusion that there is no energy losses for 0 longitudinal current flowing in the magnetosphere. The third step is the current losses. Actually, it's possible to find them in the original paper by Goldreich and Julian, because actually energy losses is a production of the current flowing in the system and potential drop. But the only difference that now these surface currents connect with the volume current flowing in the magnetosphere. We again can calculate the torque connecting with the ampere force. And very important conclusion that for local Goldreich-Julian currents, we introduce undimensional current as a longitudinal current divided by Goldreich-Julian one. If the current flowing in the magnetosphere is exactly equal to Bell-Julian current, we will have decreasing of the energy losses with inclination angle. This very important point. Let me show this picture I show for many, many years. At first glance, the energy losses are to be approximately the same order of magnitude, because even if we diminish longitudinal currents, result from the very, very small cosine theta for orthogonal rotator, but simultaneously the distance from the axis increases with absolutely the same order. But if you consider this problem in more detail, you will find that actually mean vertical component of the current flowing in the polar cap is equal to 0. And as a result, you obtain additional very small term in the energy losses. And the prediction was that in this case, it's necessary to have separatrix currents flowing in the opposite direction. And for the simplest case, when the shape of the polar cap is a circuit, its total current flowing along the separatrix is to be the 3/4 of the total volume current flowing in the orthogonal rotator. And it's very interesting, this separatrix current was obtained by numerical simulation. And of course, let me stress that in this case, current losses corresponds to the first term I have demonstrated a little bit before. So important conclusion is that the current losses certainly corresponds to the first term only. But here is extremely important result. We didn't work in this field about 10 years, but when we have returned to this area, there was a paper with Lena Nochrin, it was her first publication. We checked very carefully this conclusion, and we found that it's very important remark. Our expression for current losses is correct only if we do not include into consideration longitudinal current in the closed magnetosphere and maybe the additional currents along the separatrix. So in this case, as I demonstrated, the separatrix current is to be approximately 3/4 of the volume current, and the total current vertical component of the surface current is to be equal to 0. If some extra separatrix currents takes place, then certainly we will have separatrix currents smaller than these values, and the total vertical surface currents will be equal not to 0. Let me stress that direction of this current, which is a global current flowing along the separatrix, the direction corresponds to energy losses. In the opposite direction, it results in the increasing of the neutron star rotation. So this direction is connected with the energy losses. Okay, the fourth step is the universal solution was obtained firstly by Spitkovsky and then confirmed for many, many other papers. And here let me stress that for inclined rotator, actually we have no so definite current losses and, definite current sheet. And for orthogonal rotator, very simple expression for current, magnetic field and electric field in the pulsar wind. This solution actually contains no current sheet. This demonstrations that our very old solution, quite similar to was obtained later by numerical calculation, and even the shape of the open field lines you see also very similar what we obtained many, many years ago. So the fifth step is the pulsar breaking. How it's possible to explain the universal solution? Let me come back for a little bit and repeat that in our theory, when we have postulated the local Goldreich-Julian currents flowing in the magnetosphere, we have the diminishing of the energy losses with the inclination angle. But universal expression demonstrates the increasing of the energy losses with inclination angle. So let's try to understand how universal solution can be supported by the ampere forces connecting with the surface currents flowing in the magnetosphere. Actually, we have three possibilities. The first one is the direct current losses, but I demonstrated is as for orthogonal rotator we have some extra very small values, and it's possible to explain it as we saw it for last 2 years only by extremely high current with a factor of 1,000, 10,000 larger than Goldreich-Julian one for orthogonal rotator. The second possibility is that second term plays the main role, and I will explain you a little bit later that this may be understandable by mismatch in magnetosphere. And the third one that is connected with some additional separatrix current. Here I demonstrate the expression for electric current flowing in the magnetosphere. All people believed that the drift approximation is very nice approximation describing the currents, particle motion in the pulsar magnetosphere. At present, Gruzinov expression is more popular because it helps a lot in numerical simulation, but in the very beginning another expression was very popular. Hector Mestel includes this expression, and a very important point here is that the value of I is constant along magnetic field lines. So it was possible to use this expression in the pulsar wind, determine longitudinal non-dimensional current, and then it gives us the possibility to consider the undimensional current flowing for orthogonal rotator. It's not so large in comparison with the expression I demonstrated you here. Sorry. Here. Of course, it's large enough as well. For orthogonal rotator, this current is to be larger than local Goldreich-Julian current is a factor of approximately 100. And to say the truth, no one model such large values of longitudinal current. But you see, this current is too low to explain the energy losses for universal solution for the standard expression for current losses. Another possibility is mismatch, because remember that the absence of energy losses for zero longitudinal current, we explain it by exact compensation of the magnetodipole radiation of the central star and magnetospheric losses. But no one said that in reality, when we have longitudinal current, you see that there is a disturbance of closed magnetosphere with respect to the case when there is no longitudinal currents. And in principle, it's possible to have the energy flux from the closed magnetosphere to the open one. Because if you see the expression for for Poynting vector, you see this contains the part directed in toroidal direction, and in principle it's possible to have the situation that energy flux in this part is larger than energy flux in this part. So there will be some extra energy flux from closed magnetosphere to open magnetosphere. And another possibility is the separatrix current. And in some sense, there was some confirmation of the existence of these additional currents, because in Bay and Spitkovsky solution, they calculated the separatrix current is, well, a little bit smaller than these values. Of course, we had no small parameter in this problem, so it was not so clear whether this difference is real or it might be, I'm just near, or might be is the result of that point, that numerical simulation, in the numerical simulations, there is no small parameter. The dimension of the star is about 1/3, 1/5, but not very, very small as we have in real pulsars. Okay, the last step is an answer. You may ask yourself, what do you prefer? The first possibility, mismatch. In this case, all neutron star surfaces can work as the same we have for magnetodipole radiation. All surface works in pulsar breaking. Or separatrix currents. In this case, of course, we have the polar cap situation, that only polar cap which works in energy losses. Okay, you may ask yourself, and there is an answer. We have used numerical simulation obtained by Sasha Filippov and calculate the Poynting flux through the sphere. You see here we have 60 degrees of inclination angle, and we determine the energy flux on different radii. Here is numbers correspond to the cells, because this was produced by particle and cell, I understand. And you see, all energy flows within closed magnetic field lines. Sorry, open field lines. I'm very, very sorry. Almost all flux well inside the magnetosphere. In this case, small parameter was 1/10. The dimension of the neutron star was 1/10 of the light cylinder. In this case, all energy, approximately 100%, flows inside open magnetic field lines. No energy flux flow in open field lines. This implies that we obtain extremely important support that in reality we have current losses, but it's necessary to include separatrix currents into consideration. The last remarks concern the value of this torque. If this additional torque connects with the current flowing in the open magnetic field lines, we can evaluate these values as for orthogonal rotator, the product of A times undimensional current is to be of the order of unit. This implies that these values is very, very small, about 1/100th for ordinary pulsars. And this is okay for our model because this implies that if these values of the order of unit, let me remember again and again, in universal solution, in the Spitkovsky expression, these values for orthogonal rotator is very, very large. This implies that in our theory it was not necessary to add additional torque connecting with the separatrix currents. Okay, my conclusion. To explain energy losses for the universal solution, separatrix currents are to be included into consideration. And these energy losses connects with the standard current losses concentrated in the polar cap. But in our model, when we postulated that undimensional current, both for axisymmetric and orthogonal case, are of the order of units, the separatrix current losses can be neglected, as was proposed. So hope this is all in the understanding how neutron star and pulsar break. So thanks a lot.
Questions?